Question number 1. Find the LCM of 96 and 360 by using fundamental theorem of arithmetic. Solution. Here we have to find the prime factorization of 96 and 360. We can write 96 is equal to 2 into 2 into 2 into 2 into 2 into 3. Further we can write it as 96 is equal to 2 raised to 5 into 3. Isn't it? Similarly, we can write 360 is equal to 2 into 2 into 2 into 3 into 3 into 5. Further we can write it as 360 is equal to 2 raised to 3 into 3 square into 5. Now we can find LCM. How to find the LCM? You already know that, right? It is easy. First we should write prime factors. Then we should write their highest powers. You can see that here the highest power of 2 is 5 and highest power of 3 is 2. Therefore, LCM is equal to 2 raised to 5 into 3 square into 5, which is equal to 32 into 9 into 5 is equal to 1440. This is the LCM. Question number 2. The decimal representation of 12,857 divided by 2 raised to 1 into 5 raised to 4 will terminate after how many decimal places? Solution. First take given number 12,857 divided by 2 raised to 1 into 5 raised to 4. Any number can be represented in a decimal form easily when that is divided by 10 or its multiples, isn't it? Now, when we look at the denominator, we see that it has a combination of 2 and 5 with different powers in order to make use of m raised to n into p raised to n. That is equal to m into p whole raised to n. Here we know that 2 into 5 is 10, but 2 has power 1 and 5 has power 4. So we have to raise the power of 2 also to 4 so that both 2 and 5 have the same power and we can make use of this equation. This can be achieved by multiplying and dividing the given number by 2 raised to 3. 12,857 divided by 2 raised to 1 into 5 raised to 4 into 2 raised to 3 divided by 2 raised to 3, which is equal to. So in the denominator now we have 2 raised to 1 and 2 raised to 3. Here we have same base. We can add the powers. We get 2 raised to 4. So we have 2 raised to 4 into 5 raised to 4 in the denominator. And we can use the formula m raised to n into p raised to n, which is equal to m into p whole raised to n, isn't it? And we get 2 into 5 whole raised to 4, which is equal to 10 raised to 4. And in the numerator we have 12,857 into 2 raised to 3, which is equal to 12,857 into 8, which is equal to 102856. So now we have 102856 divided by 10 raised to 4. Now we can simplify it further by simply putting the decimal point after 4 digits from the right side and we get 10.2856 as the answer. Okay. Question number 3. Find HCF and LCM of 404 and 96 and verify that HCF into LCM is equal to product of the two given numbers. Solution. Using the factor tree for the prime factorization of 404 and 96, we have 404 is equal to 2 into 2 into 101 is equal to 2 square into 101 and 96 is equal to 2 raised to 5 into 3. To find the HCF, we list common prime factors and their smallest exponent in 404 and 96 as under. Common prime factor is equal to 2. Least exponent means its power is equal to 2. Therefore, HCF is equal to 2 raised to 2 is equal to 4. To find the LCM, we list all the prime factors of 404 and 96 and their greatest exponent as follows. Prime factors of 404 and 96, 2 raised to 5, 3, 101. Therefore, LCM is equal to 2 raised to 5 into 3 into 101, which is equal to 9696. Now, HCF into LCM is equal to 9696 into 4, which is equal to 38,784, and product of two given numbers is equal to 404 into 96, which is equal to 38,784. You can see that both are equal. Hence, we have proved that HCF into LCM is equal to product of two numbers. Question number 4. On a morning walk, 3 people step together and their steps measure 40 cm, 42 cm and 45 cm respectively. What is the minimum distance each should walk so that they can complete the same distance in complete steps? Solution. Here we have to find LCM because we have to find the minimum distance each should walk. The hint here is that if any question says to find the minimum, least or smallest number, it means that we have to find the LCM. In case we are asked to find the greatest or highest number, then you should find out the HCF. You already know this, isn't it? Therefore, now we have to find LCM of 40 cm, 42 cm and 45 cm. Factorization of 40 will be 40 is equal to 2 into 2 into 2 into 5. 42 is equal to 2 into 3 into 7. 45 is equal to 3 into 3 into 5. We did prime factorization. Now we should find the LCM. First we should write prime factors. Then we should write their highest powers. You can see that in the first line, number 2 is there 3 times. So it is written as 2 raised to 3. That means power is 3. And in the last line, we have number 3 2 times and can be written as 3 square. So 2 to the power 3 and here 3 2 times means 3 square. Other numbers 5 and 7 have powers of 1 only. So multiplying the unique numbers with their highest power, we get 2 raised to 3 into 3 square into 5 into 7. That is 8 into 9 into 5 into 7, which is equal to 2520. So LCM is 2520. This is the minimum distance they have to walk. This is in centimeter. So we should write centimeter here. Therefore, the minimum distance each one has to walk is 2520 centimeters. Question number 5. Prove that square root of 5 is irrational and hence show that 3 plus square root of 5 is also irrational. Solution. Let us assume to the contrary that square root of 5 is rational. So we can find integers p and q not equal to 0 such that square root of 5 is equal to p by q, where p and q are co-prime. Co-prime means co-prime numbers are pairs of numbers that do not have any common factor other than 1. Got it? Squaring both sides, we get 5 is equal to p square divided by q square. Pi q square is equal to p square. This is equation 1. That means 5 divides p square. So 5 divides p also. So let p is equal to 5r. Putting the value of p in equation 1, we get 5q square is equal to 5r whole square. 5q square is equal to 25 r square implies q square is equal to 5 r square. 5 divides q square. That means 5 divides q. So p and q have at least 5 as a common factor. But this contradicts the fact that p and q have no common factor. So our assumption is wrong. Square root of 5 is an irrational number and we know that 3 is a rational number. So we conclude that 3 plus square root of 5 is irrational. Okay. Question number 6. Check whether 4 raised to n can end with the digit 0 for any natural number n. Solution. Any number that ends with 0 must have prime factorization as 5. For example, 10 is equal to 2 into 5. 20 is equal to 2 into 2 into 5. So, all the numbers ending with 0 have 5 as one of the factors. If 4 raised to n ends with 0, then it must have 5 as a factor. But 4 raised to n can be written as 2 raised to 2 whole raised to n, which is equal to 2 raised to 2n. That is, the only prime factor of 4n is 2. Also, we know from the fundamental theorem of arithmetic that the prime factorization of each number is unique. Therefore, 4 raised to n can never end with 0. Similarly, same method applies to 6 raised to n and 12 raised to n, which were asked in the previous question papers. Okay, you have to use same method. Question number 7. Find the largest number which divides 70 and 125, leaving remainder 5 and 8 respectively. Solution. It is given that on dividing 70 by the required number, there is a remainder 5. This means that 70 minus 5 is equal to 65 is exactly divisible by the required number, isn't it? Similarly, 125 minus 8 is equal to 117 is also exactly divisible by the required number. We can write both the numbers as 65 is equal to 5 into 13. 117 is equal to 32 into 13. We see that HCF here is 13. HCF is equal to 13. Therefore, the required number is equal to 13. Question number 8. Show that 1 and only 1 out of n plus 1 and n plus 2 is divisible by 3, where n is any positive integer. Solution. Let n plus 1, n plus 2 be 3 consecutive positive integers. We know that n is of the form 3q, 3q plus 1 or 3q plus 2. Case 1. When n is equal to 3q. In this case, n is divisible by 3. But n plus 1 and n plus 2 are not divisible by 3. Case 2. When n is equal to 3q plus 1. Replacing n with 3q plus 1. In this case, n plus 2 is equal to 3q plus 1 plus 2, which is equal to 3q plus 3 is equal to 3 into q plus 1 n plus 2 is divisible by 3. But n and n plus 1 are not divisible by 3. Case 3. When n is equal to 3q plus 2. In this case, replacing n here, we get n plus 1 is equal to 3q plus 2 plus 1 is equal to 3q plus 3 is equal to 3 into q plus 1 n plus 1 is divisible by 3. But n and n plus 2 are not divisible by 3. Hence, 1 and only 1 out of n plus 1 and n plus 2 is divisible by 3. Question number 9. Check whether 12 raised to n end with the digit 0 for any natural number n. Solution. If the number 12 raised to n for any n were to end with the digit 0, then it would be divisible by 5. That is, the prime factorization of 12 raised to n would contain the prime number 5. This is not possible because 12 raised to n is equal to 2 into 2 into 3 whole raised to n. So, the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other primes in the factorization of 12 raised to n. Therefore, there is no natural number n for which 12 raised to n ends with the digit 0. Prime factors of 12 is equal to 2 into 3 into 2. So, 12 raised to n can never end with the digit 0. Question number 10. Prove that 3 plus 2 square root of 5 is irrational. Solution. Let us assume to the contrary that 3 plus 2 square root of 5 is rational, so that we can find integers a and b not equal to 0, such that 3 plus 2 square root of 5 is equal to a divided by b, where a and b are co-prime. Rearranging this equation, we get 2 square root of 5 is equal to a by b minus 3. That implies square root of 5 is equal to a minus 3b divided by 2b. Square root of 5 is equal to a divided by 2b minus 3b divided by 2b. That implies square root of 5 is equal to a divided by 2b minus 3 divided by 2. Since a and b are integers, we get that a divided by 2b minus 3 divided by 2 is rational, and so square root of 5 is rational. But this contradicts to the fact that square root of 5 is irrational. So we conclude that 3 plus 2 square root of 5 is irrational. Teachers can open the door, but you must enter it yourself. Thanks for watching.